Right, today we're talking about Chapter 1, Section 8, Absolute Value Equations. Alrighty, so let's see. I think this is useful. I mean, obviously, but yeah, we'll go and talk about it. But it probably won't make too much sense until we actually get started on them. So, okay, I think that's okay. Alright, so starting from the top, in the review section 1, we see that the absolute value of a number a, written as the two vertical bars, the a in between two vertical bars, represents the distance from a number a to 0 on the number line. So we know absolute value is a distance. Okay, so for instance, if someone were to ask me, hey, how far away is Walmart? I wouldn't say, oh, it's negative 3 miles away, right? It's a distance, so it's 3 miles away from me. And that's how we refer to absolute value, as a distance. Okay, so let's go ahead and look at this. The absolute value of x equal to 5. Okay, so what this is saying is that the value of x, some unknown, is 5 units away from 0. Therefore, it could be either positive 5 on the number line or negative 5 on the number line. Okay, now if we look at the absolute value of x is less than 5, okay, well, let's think about all the values that are less than 5. Well, obviously we go 4, 3, 2, 1, 0, right? That's true. But also, you know, we're talking about a distance of less than 5, so we would also say, you know, negative 4, negative 3, negative 2, negative 1, right? So that's how we see this as a solution. So whenever we see the absolute value of x is less than 5, we're saying that some x, some unknown, has a value, or I'm sorry, is some x, some unknown, is less than 5 units away from 0. So since this is 0, it could be any number to the left or right of 0 as long as it doesn't go above the number 5. Okay, that's the so that's equal to and less than. And next we'll talk about greater than. Alrighty. So looking at this, if we have some value of x, wait, that's figure 10 less than. I believe that is a typo. Yes, this is definitely a typo over here. It's supposed to be a greater than 5. We've already done the less than 5. So let's do a little bit of okay. So if we were to say the absolute value of x is greater than 5, okay, well, what are some numbers that are greater than 5 units away from 0? Again, the obvious ones would be 6, 7, 8, 9, 10, and so forth, right? The not so obvious ones, but they will become obvious once I say them, would be, you know, negative 6, negative 7, negative 8, negative 9, right? Because, you know, negative 9 is how many units from 0? Well, it's 9 units from 0, right? So therefore, that has an absolute value that is greater than 5 units away. Okay. Next, we're going to look at this table. This table is definitely big time, something that you need to memorize. Now, here's the thing. I say memorize, but I feel like feel like memorizing this specifically again takes up brain cells. Okay, so imagine that you are, you know, on stage and you're acting, right? Obviously, what you say is important, okay, but verbatim maybe not so much. So if you're trying to convey a thought, you can convey that thought without saying the exact same words that are on the script. I don't know if that's a good example or not, so I'll stop. But anyways, my point is this down here, don't spend time memorizing it. If you can just remember the concept, then you'll be okay. And of course, the concept is written inside of those symbols, the equal sign, the less thans or greater thans. Okay. Now, obviously, over here we have how we're going to set up those equations, and we're just going to jump straight into examples instead of going through this rigorously. But we will definitely come back to this as a demonstration of, hey, see, we thought our way through the process, and by thinking our way through the process, we see that we do indeed get back to our definitions here. So let's get started on that. Okay, so this one is starting out as an equal sign. Okay, so we just thinking about this intuitively. Okay, so if let's rewrite this. 1 minus 3x is equal to 4. Okay, so just think about this intuitively. It doesn't matter what is in here. Does not matter what is in there. Okay, as well right now. We know that once the x gets fleshed out, that we know that what's going to be in there is either going to be a positive 4, right? Because the absolute value of 4 is 4, or negative 4, right? Because the absolute value of negative 4 is also 4. Okay, so we know what is inside here must be either equal to 4 or negative 4, because that's the only way the absolute value of it is going to be equal to 4. Okay, so with that said, since we know it's going to be either 4 or negative 4, what we're going to do is we're just going to make a simple equation, 1 minus 3x, we're going to say is going to be equal to 4, and 1 minus 3x is going to be equal to negative 4. That's it. We just set up two separate equations, and then we're just going to solve. Okay, so solving for x here, starting with the left side here. So if we subtract 1 from both sides and divide by negative 3, we end up with x is equal to negative 1. And on the right side over there, if we divide if we subtract 1 from both sides, we have a negative 5 on the right. Divide by negative 3 on both sides, so we've got x is equal to a positive 5/3. Okay, and that's the solution to this equation. Okay. Now, obviously, we can and we will for this particular problem, kind of do some mental math and plug them back in, right? So if we plugged in a negative 1 there, what's 3 times negative 1? Well, that's negative 3, right? So a minus a negative 3 is going to be a plus 3. So 1 plus 3 is 4, and the absolute value 4 is indeed 4. Okay, so that works. Next up, we're going to plug in a 5/3 up here. Okay, well, 3 times 5/3 is 5. Okay, and then 1 minus 5 is negative 4. The absolute value of negative 4 is indeed 4, so we are done. Okay, so what we did here was, again, the thought process is just an intuitive, logical thought process, right? But if you want to think about this rigorously and kind of set rules for yourself, if you have an equal sign there, an equal sign, then what you're going to do is you're going to set it equal to that number for 1. You're going to set oh, sorry about that. That came up on me real quick. What was I saying? All right, you're going to put what's in your absolute value symbol equal to just that number, but then you're going to make it equal to the negative of that number. Okay, and as I said before, we'll go back to this. Notice how that's exactly what we do here. Okay, we set what's inside the absolute value equal to the positive and negative of what the number is right here. Right, and that's how we do equal signs. Equal signs are pretty easy. Matter of fact, I think they're all kind of easy. The only hard one I think that you might struggle with wrapping your brain around is the greater than. Oh, this is ridiculous. Okay, so let's get on all these. All right, starting with A. The way you solve these algebraically are pretty much how you imagine you would. What we need to do is we need to isolate the absolute value symbol. Okay, and once we isolate the absolute value symbol, then we can proceed with our problem. Okay, so A, I'm going to go ahead and rewrite this by subtracting 5 from both sides. Okay, so it's going to be negative 2, 1 minus 3x, that's the value of that. And I said we subtracted 5 from both sides, so we're going to have is equal to negative 14. Okay. Next what we're going to do is we're going to divide both sides by negative 2. So by dividing by both sides by negative 2, we're going to have 1 minus 3x is equal to, well, negative 14 divided by negative 2, that's going to be positive 7. All right. Now at this point, I can now set this up as two equations, right? Because this, looks like this problem. So I can set this up into two equations. So one equation is going to be 1 minus 3x is equal to positive 7. So basically just rewriting it, right? Just dropping the absolute value symbols. And next we're going to do 1 minus 3x is equal to a negative 7. Okay, and of course just changing the sign there. Alrighty. Well, let's do this. So if we subtract, starting with the left side here, so if we subtract 1 from both sides, we're going to have a, looking over here again, we're going to have a negative 3 is negative 3x, sorry, is equal to a positive 6. And divide both sides by a negative 3, so we're going to have x is equal to a negative 2. All right. And then the other side, we're going to subtract 1 from both sides, so we're going to have a negative 3x is equal to negative 8. And then we're going to divide both sides by negative 3, so we're going to have x is equal to a positive 8/3. And that's A. Next up, we have B. Okay, so lucky for us, it's already we don't have to do any sort of computation to start this out, do we? Because the absolute value symbol is already isolated, right? So instead, what we can do, so instead what we can do is go ahead and reduce this to I won't say reduce it, huh? So instead what we can do is rewrite this into two separate equations, right? So one of them's going to be 5x minus 1 over x plus 3 is equal to 11. And then basically the same thing, except now we're going to write a negative 11. Okay. All right, so, this is actually a pretty good problem. So solving this for x is going to be a little tricky. So follow along, because there are a lot of problems that are kind of like this, where we're going to have x's on both sides. So maybe it's not as tricky as I thought. Hang on, let's just solve it instead of me talking, huh? So let's go ahead and multiply both sides by x plus 3. So that means the left side here, we're going to have 5x minus 1 is equal to 11x plus 3. Again, what I did here was I multiplied the entire problem by, is this not working? There we go. By x plus 3. And when I distributed here, it canceled there. And then of course when I distributed here, that's why I got that. Okay. All right, continuing on, we're going to have 5x minus 1 is equal to 11x plus 33. And this isn't as cool as I thought it'd be, never mind. But anyways, so what we're going to do here is I'm going to go ahead and subtract 5x from both sides and also subtract 33 from both sides. So by doing that, I'm going to have negative 32 is equal to 6x. So that's 16 over 3, 7. Sorry about that. Let's try that again. Okay, so we're going to subtract 5x from both sides, like this. And so by subtracting 5x here, we've got a 6x, and then subtract 33 here. Yeah, I did do that. Okay, so by doing that, we have negative 34. I know that was a little messed up. All right, and then of course dividing both sides by 6, we're going to end up with x is equal to, it's going to be a I'm going to run out of room. Let's not do that second row there. I just don't want to jumble it all up there. Okay, so let's try this again. So same procedure, right? But I'm going to go ahead and put the x on the left side. So let's go ahead and go that route actually. So let's do negative 6x right? Because I'm going to end up putting the x on the left side anyways. And that's going to be equal to 34. And that makes it easier to see now. And if we divide both sides by a -6, we're going to end up with x is equal to negative 34 over 6, which can be reduced down to a negative 17 over 3. Okay, so that's the left one. Now the right side, we're going to try to make this nice and neat as well. Same thing, we're going to multiply both sides by x plus 3. So we're going to end up with a 5x minus 1 on the left. It's going to be equal to a negative 11. And then x plus 3 on the right. And we're going to distribute that negative 11 through. So we're going to open that 5x minus 1 is equal to negative 11x minus 33. And then let's go ahead and put the x on the left side again. So we're going to add 11x to both sides. So we're going to end up with a 16x over here. And we're going to add 1 to both sides. So we're going to end up with a negative 32 over here. And so that means we're going to end up with, we divide both sides by 16. We're going to end up with x is equal to a negative 32 over 16, which is going to be simply be negative 2. Whew, okay. Believe it or not, I think C is actually easier. So let's jump to C now. Mainly because, look, nobody likes fractions, right? I don't know why we gotta do fractions all the time. All right, so C, again, it's already broken down to us a little bit easier. So let's go ahead and write this as x squared minus x minus 8. And it's going to be equal to a positive 4. And then we're going to have x squared minus x minus 8 is going to be equal to a negative 4. Okay, so let's solve the left one. If we subtract 4 from both sides, we're going to have x squared minus x minus 12 is equal to 0. And then this factors into, so what are my factors of 12 that give me a negative 1? Looks like it would be a 4 and a 3, so we're going to say x minus 4, x plus 3 is equal to 0. And my solutions will be x is equal to, let's put it in green. I like my solutions in green. For some reason we're not attaching, there we go. X equals to 4, x equals to negative 3. Okay, so that's that. And then the right side, I have a feeling the right side is not going to be as pretty. So we've got x squared minus x, and then we're going to add 4 to both sides. So we're going to have negative 4 is equal to 0. What are my factors of 4? That'll give me a negative 1. Bad news. We're going to have to do the quadratic formula. Okay, because my only factors of 4 are 1 and 4 and 2 and 2, right? And neither of those will give me the negative 1 needed here. So we have to do the quadratic formula. X squared minus x minus 4. So we're going to end up with, looks like negative, okay, so we're going to end up with x is equal to 1/2. And then I guess we can just put plus or minus, right? Because we have this just the two different solutions. So plus or minus the square root of 17 over 2. Okay, and again, that's just the quadratic formula. And so that's how we do C. And D looks like it's going to be terrible because we have that radical. So let's go ahead and knock that out. I don't think I wrote C over here. Let's do C. Okay, D. All right, again, we don't have to do any sort of algebraic manipulation to isolate the absolute value symbol. All we have to do is simply rewrite the problem. So we've got 2x plus 9 minus x is equal to 3. And then the square root of 2x plus 9 minus x, and that's going to be equal to a negative 3. Here we go. So we're going to go ahead and add the x to both sides. So we're going to have the square root of 2x plus 9 is going to be equal to x plus 3. And then we're going to square both sides, okay, because we need to get rid of that radical. Of course, if we square the radical, that just becomes 2x plus 9. And then the right side, again, the formulas that I told you need to memorize, it just becomes x squared plus 2ab, so it's going to be plus 6x plus 9. Let's move everything to the right side. So we're going to end up with a 0 is equal to x squared. It looks like we subtract 2, so we're going to have a plus 4x. And then the 9's cancel out, so that's nice. And then we've got 0 is equal to, we're going to factor an x out, so we're going to have x, and then what, x plus 4. So therefore, my solutions here would be x is equal to 0, and x is equal to negative, okay, negative 4. Okay. Oh, my goodness. All right, so that's one. Now the next one, I'm going to go and add x to both sides again. So we're going to say the absolute value of 2x plus 9 is equal to x minus 3. We square both sides again. We have the square root, the square root of 2x plus 9 squared. Again, that you just pretty much write down the radicand there. By the way, when I say radicand, I'm sorry, I should have said this before. When I say radicand, the radicand is just simply the number inside of the radical. Okay. And then, of course, we do our x squared minus 2 times a times b, so it's going to be minus 6x, and then plus 9. And move everything to the right side again, so we're going to have 0 is equal to x squared, so it's like minus 8x, and then the 9's cancel again, so we end up with, oh wait, we have to do the factoring thing, so 0 is equal to, we're going to factor an x out, so we have x minus 8, and so my x values here, x is equal to 0, and x is equal to 8. Whew. All right, so let's see. Besides the computation on all four of those, okay, the computation that we did on A through D is computation that we have seen before. Okay, so it shouldn't be anything new to you. We've done that computation. The only new thing that's being introduced here is just the absolute value symbol, right? So, for instance, if you were given this particular problem on a section, you know, maybe I think it was, did we do it Monday? I don't know, it's Monday or last Wednesday. It's the exact same type of problem that we've done previously. And of course, that can be said for all four of these once we got rid of the absolute value symbols. So I believe that takes care of the equal sign. So let's get to the less than. Okay, so this is, yeah. Now we're going to talk about less than signs. Okay, so my pen somehow is skipping, I guess. Oh, all right, 1 second. I've actually had this problem last semester. I don't know how it skips, but I'm going to have to use my finger. Yeah, that's me trying to write with my pen. That's not good. Alright, so for the rest of today, I'm going to write with my finger. Anyways, so example 3, solve the absolute value less than inequality. Okay, so less thans, I think, are a lot easier because unlike equal tos or equal signs, we don't have to write two equations. We just have to make one equation. So here's how we do this. Okay, so let's again think back to the number line that we saw earlier. Less than here. Okay, looking right down here. Well, maybe I should not write it in white. Looking down here, we have the absolute value of x is less than 5. Okay, so what that means is, again, that means that that distance is going to be less than 5 units from 0. Okay, and in order to set that up is super duper easy. Just like before, what we need to do is we need to isolate the absolute value symbol. So let's go ahead and isolate that. Then we're going to subtract 2 from both sides. We've got less than or equal to 5. Okay. All right. And then once we get to here, what we need to do is we need to make the three-sided inequality now, right? Because if the absolute value of 4x minus 3 is less than or equal to 5, then that means it can also be, again, negative 4, negative 3, negative 2, negative 1, right? So what we're going to do is we're going to drop the absolute value symbol, and we're going to go ahead and put a negative 5 on the left side, like this. Okay, and of course we have the less than or equal to here. And then we're going to put 4x minus 3, and then we're just going to put the 5 on this side. Okay, so notice what I did there. So basically what I do is I took off the absolute value symbols, okay, and then I just put the inequality out here, and then negative 5 to the left of it. And that's it. That's literally it. That's all you have to do for these less than or equal to's. And of course we have to solve from here, but setting up the problem, again, is the new introduction, is the new part for you. And then we're going to solve it. So let's solve this problem. So if we add 3 to both sides, we're going to end up with a negative 2 is less than or equal to 4x, which is less than or equal to 8. And then we divide all 3 sides by 4. So we end up with negative 1/2, right? Because we divided it by 4 is less than or equal to x, which is going to be less than or equal to 2. Right? And that's my solution, right? It doesn't necessarily say how they want these put. Okay. So if I want to put this in set builder notation, again, my favorite, right? Because all I have to do basically is do a little squiggly line, x, such that, well, what should x be? Well, I just got to basically rewrite what my answer was, right? Oh, so sorry, this looks a little horrible. My finger's a little bit too big for this. That's not terrible. Okay, so that would be set builder, and of course, interval notation is just basically, again, rewriting this. Just don't put an x there, right? So we're going to say negative 1/2 to 2. Okay, and then do we use parentheses or brackets? Well, looking here, next to the negative 1/2 is a less than or equal to, so that's going to be a bracket there. Over here, it's also in less than or equal to, so that's also going to be a bracket. Okay, so those are 2 ways to write our solution, and that is less than. And I really hope I don't have the 4s. Okay, good. We're going straight to greater thans now. Okay, so that was the less thans. Now we're going to talk about greater thans. Now greater thans is going to be different, but again, if you think about it intuitively, you just slow down, it will make sense. Okay, obviously you can kind of memorize things and say, okay, so if it's an equal sign, I'm going to set up 2 equations. Okay, if it is a less than sign, I'm going to set up 1 equation, but it's going to be a 3-part inequality. And if it's greater than, okay, so let's talk about greater than. If I said the absolute value of something, let's do this like I did. Let's do this. Okay, so similar in the vein of what I did earlier. If whatever is inside of this inequality, okay, I know that its absolute value is going to be greater than 3. Okay, so again, what are some numbers that are greater than 3? Well, 4, 5, 6, 7, 8, 9, 10, so on and so forth, right? All right. Well, we can also go the other way. Negative 4, right? The absolute value of negative 4 is 4, and 4 is greater than 3. Negative 5, the absolute value of negative 5 is 5, and 5 is greater than 3, and so on, right? Hopefully you can see what's happening here. So what we're going to do is we're going to again set up two equations, okay? And the way we set these two equations up, I guess I can keep that. No, I'm going to make it a little smaller because... All right, so the way we set these two equations up is we're basically going to rewrite the equation, but without the absolute value symbols. Jeez, this is horrible. There we go. Without the absolute value symbols. And then what you're going to do is you're going to focus on here, and you're going to flip the sign and the inequality. So if it's a greater than, we're going to make it a less than, and if it's a positive 3, we're going to make it a negative 3. Okay, so we're going to change both of those. So let's go ahead and let's actually highlight what we're doing here. Greater than 3 and 5x plus 1, and we're going to say less than negative 3. Okay, and again, that makes sense, right? Because if the absolute value of something is greater than 3, then obviously everything greater than 3 is going to work, but everything less than negative 3 is also going to work, right? Again, the absolute value of negative 10 is 10, and 10 is greater than 3. So that's how we set that up. And then, of course, we just do the arithmetic here. So starting on the left side, if we subtracted 1 from both sides, we have 5x is greater than 2, and then therefore we have x is greater than, what did I say, 2/5. And on the right side, if we subtract 1 from both sides, we have 5x is less than negative 4. And if we divide both sides by 5, we end up with x is less than a negative 4/5. Okay, and then that would be my well, I wouldn't say that's my solution. Okay, so here's what we're doing. Let's put this again in. Let's do this. Let's put a little line here. Okay, so in set builder notation, again, my favorite, right? Set builder notation. Basically, I just rewrite. So I would say x, and then x such that what? Well, x is going to have to be greater than 2/5, or x is going to have to be less than a negative 4/5. Okay, and that's set builder notation. And if I want to put this into interval notation, okay, so interval notation, again, this is just going to have to be kind of a thing where you could, if you wanted to, draw a number line, but hopefully, if you haven't done your homework yet, you get started on your homework for 1.7, and then you can kind of maybe visualize this, right? So if this is less than negative 4/5, and this is greater than 2/5, then we know that this side is going to be the left side of the number line, and this is going to be the right side of the number line, right? So we know that we can say, let's actually, I don't like, let's change this color. Let's change it to red and red. Okay, so we would say negative infinity into negative 4/5, and it's going to be unioned with 2/5 to infinity. Okay, so again, it's what we did the other day. All I basically did was, this represents this one, right? And this inequality represents this interval. And so those are my two solutions, writing them in both set builder and interval notation. Obviously, your homework is going to ask for both intermittently. Alrighty, so what does this one have in store for us? Well, let's start, okay? So what we need to do is we need to isolate my absolute value symbol again. So what I'm going to do starting out is I'm going to subtract 7 from both sides. So I'm going to end up with a negative 2 on the absolute value of 1 minus 4x is less than or equal to, when I say I subtract 7 from both sides, it's going to be negative 16. Okay. I need to isolate that absolute value symbol, so I'm going to divide both sides by negative 2. All right, well, when I divide both sides by negative 2, I'm going to flip the inequality, right? So we're going to have the absolute value of 1 minus 4x. I divide both sides by negative 2, so it's going to be a greater than or equal to 8. Okay. And then from here, it's a greater than or equal to, so I'm going to set up two different equations, right? So one equation is going to be 1 minus 4x is greater than or equal to 8. Again, just rewriting it and dropping the absolute value symbol. And then the next equation is going to be 1 minus 4x, and it's going to be less than or equal to negative 8. Okay, again, all I do is I flip the sign. I flipped the inequality and changed the sign. So I flipped it from a greater than to a less than, and from a positive 8 to a negative 8. Okay, and then I solve from here. So if I subtract 1 from both sides, it looks like I'm going to have a negative 4 is greater than or equal to a 7. And then if I divide both sides by negative 4, I'm going to have x. And again, I'm dividing by a negative 4, so I'm going to flip the sign again, right? So it's going to be x is less than or equal to 7, negative 7/4. Okay. And then on the right side, we're going to again subtract 1 from both sides. So we have negative 4x is less than or equal to a negative 9. We're dividing by a negative number, so we're going to end up with x is greater than or equal to, again flipping the sign, would be 9/4, positive 9/4. Okay. And those are my two solutions, and let's go ahead and write those in both set builder and interval. Okay. Alrighty, so set builder notation, let's go ahead and do the thing where I did what I did earlier, where I just drew a line underneath it. Okay, so set builder notation, again, super easy. What I'm going to do is I'm going to do my little squiggle. Oh, I don't want it yellow. Squiggle x such that, well, what should x be? Well, x is going to be less than or equal to a negative 7/4, or it's going to be greater than or equal to a positive 9/4. Okay. And again, interval notation. So interval notation, if you want to put this on a number line, you're more than welcome to. But we know if we were to, this is actually in a good number line-ish kind of way, right? If we had our number line and we had negative 7/4 here, then we know we would go all the way to negative infinity. And if we had a positive 9/4 here, we'd go all the way to infinity there as well, right? So we know we're going to go from negative infinity to negative 7/4, and then from a positive 9/4 to infinity. So I would say, again, in parentheses, oh no, is my finger not working now? Okay, good. From negative infinity to a negative 7/4, and we're going to union that with, ooh, almost messed that up. That's a bracket there, right? Because this is an or equal to. Union with, and again, this is a bracket as well, because we're including it, 9/4. That doesn't look like a good 4. 9/4 to infinity as well. Okay, and again, just to say again, the infinities will always have parentheses, right? Because we're not going exactly to infinity. The infinity is not a number; it's a concept. So we do indeed put a parentheses there. All right, and yeah, this is the last one. Okay, so this is really fun. So normally what I do, if we're in the classroom, what I do is I make the last problem an exit problem, right? So you pay attention during class, because obviously I get done really quickly with my lectures, and so if you pay attention in class, you can do the exit problem and get out sooner. But if you didn't pay attention in class, you're going to be sitting there the whole time because, well, you're not going to be able to do the exit problem. And that's kind of unfortunate for this one because this one's actually a pretty fun exit problem type of problem. And I don't think I've ever had anybody actually get all 6 of these correct. And the reason why is because they are a little tricky. Lucky for you, we're going to have to go through all of them. Okay, so there is no exit problem involved for you. Let's just get started. So let's start with A. Okay, so A, the absolute value of 3x minus 2. So the thing about these, and why I think they're so fun, is because you have to think about them logically. Okay, well, A reads the absolute value of 3x minus 2 is equal to 0. Okay, well, what do we know about absolute values? Okay, well, we know that absolute values cannot be equal to a negative number. Okay, so what that tells me is that the absolute value of 3x minus 2, if it's equal to 0, that's all it can equal to. That there is absolutely no other value that you can equate it to, right? So if we were to go back and think about how we solved absolute values with an equal sign, if you recall, what we did was we said, okay, 3x minus 2 is equal to 0. 3x minus 2 is equal to a negative 0. Okay. Well, the thing is, negative 0 doesn't make sense. So what we could do is we could just basically stop at 3x minus 2 is equal to 0. Okay, and I'm going to rewrite that a little bit smaller so I can do computation. Okay, so we can pretty much stop there. We don't have to write equal to negative 0. And then we can just solve, right? So we add 2 to both sides. We divide by 3. We have x is equal to 2/3. That is the only solution possible for example 6, right? Because if I put in anything else, it will not be equal to 0. So 2/3 is the solution, right? Now, obviously, I guess I feel like you would have figured this out anyways, right? But I kind of gave away what B was, okay? Because I said that the absolute value of you cannot have a negative absolute value, right? Again, if somebody says, hey, how far away is Walmart? I'm not going to say negative 4 miles, right? That's just not the way to say it. It's not the correct way to say it. So B, we have the absolute value of x plus 6 is equal to negative 4. That does not make sense. There's no absolute value of anything that will equal negative 4. So the solution set is going to be the empty set. Okay, you cannot solve for that. Okay, and then that kind of leads us into C, right? We have the absolute value of 7x plus 5 is less than or equal to 0. Okay, well, we know that the absolute value of something cannot be less than 0. Okay, so you might be tempted to say, oh, well, that's also the empty set. Okay, but obviously it's not going to be, right? Because I prefaced it a little weirdly, didn't I? Because we also have the or equal to sign. Okay, so what we can do, so what can happen here is that the absolute value of 7x plus 5 can be equal to 0. Okay, it cannot be less than 0, but it can be equal to 0. So we're basically going to set it up like we did our very first problem. 7x plus 5 is going to be equal to 0. And of course, if we subtract 5 from both sides, and then divide by 7, we have x is equal to a negative 5/7. Okay, so that would be C. And again, you just have to kind of think about these intuitively. So these are tricky, right? Matter of fact, let's just go ahead and go to D because I feel like that's a pretty easy one, isn't it? We have the absolute value of 3x minus 4. Let's put D. 3x minus 4 is less than negative 6. Okay, well, if the absolute value of something cannot be less than 0, then we surely can't be less than negative 6, right? That doesn't make sense. So that is also going to be the empty set. Okay. And then E, we have the absolute value of 8x minus 3 is greater than 0. Okay, so that's interesting. We're going to put that on the next page. I think these problems are fun. It's better than the mindless computation that we do most of the time. So E has the absolute value of 8x minus 3 is greater than 0. Well, so if we were to think about this again logically, all right, we're essentially going in the opposite direction. So we said that we can't have, on C and D, we essentially said, we can't have a negative absolute value, right? Well, E is saying the absolute value of x minus 3 is greater than 0. Well, all absolute values are going to be greater than or equal to 0, aren't they? Because, again, that's just the definition of absolute value, right? But looking at 8x minus 3 is greater than 0, there is one solution that would make that a false statement. Okay, and that one solution would be if we had the absolute value of 0. Okay, well, what is the absolute value of 0? Well, the absolute value of 0 is 0. And is 0 greater than 0? No, right? It is equal to 0, but it's not strictly greater than 0. So what we would have to do here is figure out what makes this equal to 0 and eliminate that from the possible solutions. So what we'll do is we'll say, okay, so 8x minus 3, we're going to set it equal to 0, okay, because we're going to figure out what it cannot be. Okay, and by equating it to 0, we're going to end up with x is, we had 30 both sides, equal to 3/8. Okay, so when x is equal to 3/8, if I plugged in 3/8 over here, okay, and let's just go ahead and do some mental math. What is 8 times 3/8? Well, that's 3, and 3 minus 3 is 0. Okay, and so we figured out what we cannot use. That makes sense, because 0, again, the absolute value of 0 is not greater than 0. So what this tells me is I can use every single possible number you can ever think about except for 3/8. Okay, because 3/8 is what makes that absolute value equal to 0. So what we're going to do instead is we're going to say my solution set here is going to be from negative infinity to a positive 3/8 unioned with 3/8 to infinity. Okay, so what that means, again, just looking at this logically, I can use every single possible number you can just ever think about, right? Again, the absolute value of, negative 1 billion is 1 billion, and 1 billion is greater than 0. So again, it doesn't really matter. But the only number that I cannot use is 3/8, because when I substitute that in, I get the absolute value of 0, and that is not greater than 0. Whew, I'm going to dry mouth there. All right, and then lastly, we can do it on this page because it's pretty darn easy. There's the D, no, it's F, Sherman. F, okay. So we have the absolute value of 1 minus 9x is greater than or equal to negative 5. So now, again, we're going the opposite thought process here. If we can't have a negative absolute value, well, then this absolute value is always going to be greater than or equal to a negative number, isn't it? So what that means is that all real numbers, I can use anything, and it will always have a value greater than or equal to 0. Okay, there's not a number you can think of that would make the absolute value of 1 minus 9x less than 0. So obviously it will always be greater than or equal to negative 5. So my solution set here is going to be from negative infinity to positive infinity. Okay, now real quickly before I do end this lecture, these 6 problems were a little tricky compared to the previous examples. Now, most of your homework is going to be like the previous 5 examples. Okay, and how will you know when you're going to be tricked or not? Well, truth is you don't. Okay, what's going to happen here is you're going to look at these inequality or these absolute value inequalities or equalities, and you're going to first think about, hey, does this make logical sense? And then once you figure out if it makes logical sense, then you can proceed with actually solving the problem. So let's go ahead and real quickly kind of look at some examples. Okay. Once you start off, okay, oh, this is actually a pretty good one. Okay. So just because this says a negative 9 there doesn't mean you're gonna be like, oh, it doesn't. There's no solution here. Okay. Because obviously, well, A would be this page. Obviously, whenever we fleshed it out and got the absolute value symbol by itself, we notice that we do indeed have a positive number over here, right? Because we divide both sides by a negative number. Okay, but try and figure out if your absolute value inequality makes logical sense. Okay, and of course, if it does or doesn't, then you can proceed with your solution that way. But anyways, that's all I got for that. That concludes today's lecture.